Hi, welcome to our Pharma Topics channel. Welcome to the second unit of the computer-aided drug design. B.Pharm 8th semester syllabus we are going to discuss. In this, we are going to see the quantitative structure-activity relationship. This covers structure-activity relationship versus quantitative structure-activity relationship, history and development of QSAR, types of physicochemical parameters, partition coefficient, Hammett substitution, substituent, Taft's steric constant, Hansch analysis, free Wilson analysis. And in 3D QSAR, we are going to see about COMFA and COMSIA. Previous unit I have given in the description box, that also you can go through it. And the notes are available in Amazon Kindle also. If you need, you can purchase it. It will be useful for your examination point of view. So let us go into the unit. First, they may ask what is QSR? Define QSR. QSAR is the study of physicochemical properties of series of compounds which is related to their biological activity. The biological activity is represented as log 1 by C, and it is the function of physicochemical properties. There may be n number of properties like IC50, ED50, Km, Ki. The QSAR is a computational or mathematical model. It gives a equation, a linear equation, such that when you put any compound in it, it can predict the activity. Physicochemical properties include electronic, steric, and hydrophobic properties. What is the difference between SAR and QSAR? SAR is the structural activity relationship. It tells about the 3D structure of a molecule and its biological activities. But the mathematical relationship between the biological activities and measurable physicochemical properties is called QSAR. SAR is related to drug discovery and development. It includes study of functional groups which play an important role in biological activity. QSAR is related to drug design, which includes rational modification of biological effect of a compound by changing its chemical structure or inserting new chemical groups. SAR does not include lead optimization, whereas QSAR includes lead optimization. SAR is not a special case of QSAR, but QSAR is a special case of SAR where the relationships become quantified. The next is what are the objectives of QSAR? QSAR actually quantitatively correlates the relationships between chemical structure alterations and the respective changes in the biological activities. It optimizes the existing leads to improve their biological activity. It predicts the biological activities of untested or sometimes unavailable compounds also. The advantages of QSAR: it helps in prediction of biological activities of a large number of compounds with little or no prior wet lab studies, that is assays. It is a green chemistry approach since there is no chemical waste. It is useful in reduction of annual testing with large data set libraries of compounds. It's an economical approach, saves the cost of drug invention and also reduces the time for drug discovery. What is the history and development of QSAR? They may ask this question. Several scientists have contributed for the development of QSAR. In 1865, Crum, Brown, and Fraser first expressed the idea that there is a relationship between the activity and the chemical structure. In 1893, Richet correlated the toxicities of simple organic molecules with their solubility in water. In 1935, Hammett correlated the effect of addition of a substituent on benzoic acid, and he established a linear free energy relationship principle. In 1900, Mayer and Overton found linear relationship between toxicity of organic compounds and their lipophilicity. In 1962, Hansch published free energy related model to correlate biological activities with physicochemical properties. In 1964, Free Wilson formulated a model which is a simple sum of contributions from different substituents. In 1998, Cho and workers developed inverse QSAR, which defines the molecular descriptors essential for desired biological activity. In 1999, Labute developed binary QSAR for high throughput screening. So what are molecular descriptors in QSAR? Molecular descriptors, they describe the characteristics of a molecule in numbers which is generated by some algorithms. The numerical values of descriptors are used to quantitatively describe the physical and chemical information of molecules. The molecular descriptors in QSAR studies are 1D QSAR, it's a one-dimensional representation calculated from the molecular formula, example molecular weight, molar refractivity, log P. 2D QSAR, it's a two-dimensional representation of a molecule such as size, shape, and electronic distribution in a molecule, such as number of atoms, number of bonds, connectivity indices. 3D QSAR represents the conformations of a molecule, such as van der Waals volume, solvent accessible surface area. 4D QSAR, it represents the combination of atomic coordinates and conformations, example 4D fingerprints. 5D QSAR, it represents the ensemble of different induced fit models in 4D QSAR. 6D QSAR, it's a six-dimensional representation of entropy dimensions. The parameters used in QSAR studies, they are hydrophobic parameters such as partition coefficient log P, hand substitution constant, distribution coefficient log D. Electronic parameters are Hammett substitution constant, Swain and Lupton parameter, ionization constant, and chemical shifts. Steric parameters of a molecule are Taft's constant, molar refractivity, molar volume, van der Waals radius, and Verloop steric parameter. Quantum chemical parameters are atomic net charge, energy of the highest occupied molecular orbital, and energy of the lowest occupied molecular orbital. Spatial parameters are just descriptors, radius of gyration, and shadow indices. What is log P? It's a very important question. They may ask explain about log P. This is a parameter related to absorption of a drug, how it crosses the lipid cell membranes to exert its biological action by interacting with the target receptor. It determines the hydrophobicity of a molecule, which is measured experimentally by testing the relative distribution in N-octanol water, that is partition of the compound between aqueous and non-aqueous phase. So it is a graphical representation of log 1 by C, that is biological activity, and log P. So what is C log P? It is the partition coefficient of the compound, which is determined experimentally. Plain log P is determined by computational tools. C log P is determined experimentally. Log D, it is also called distribution coefficient. It is defined as the ratio of concentration of the unionized and ionized compound between an organic solvent and aqueous medium. Hand substitution constant, it's also very important. They may ask in short notes. Hansch is a scientist, he has derived constants for contributions of different substitutions to the partition coefficient, which is also called lipophilicity constant. He derived this action, there is equation phi x equal to log px minus log ph. You can see every substituent he has given a particular value which you can substitute and predict the lipophilicity. If the pi values are positive, the substituent is hydrophobic. If it is negative, they are hydrophilic substituents. Next is Hammett substitution constant. Hammett predicted the equilibrium constant, that is the rate constant for chemical reactions, by introducing substituent constant. He studied the influence of electron withdrawing or electron donating groups and proposed electron withdrawing groups have positive value and it is negative for electron donating groups. It is the measure of inductive and resonance effect. The para substituent has greater resonance, whereas a meta substitution has lesser values. There is no value for ortho substitution. So he derived this equation. Next is Taft's steric constant. It is what is it? What is its importance? It is a steric factor represented by ES. It's a measure of bulkiness of a particular group in a molecule and its effect in interaction with the receptor. He has derived the values for it. He has derived the equation for it. This is called Taft's steric constant. Next is molar refractivity index. It's the measure of volume occupied by an atom or a group. Verloop steric parameter, it is measured by software program called Sterimol, which measures the standard bond angles, van der Waals radii, bond length, and possible conformations for the substituents. So you can use these diagrams in your examination point of view. What is Hansch analysis in QSAR? It's a very important question. It's the most popular method in QSAR, which is also called extra thermodynamic or linear free energy approach. Hansch proposed that the drug should get transported first to reach the binding site, and then it is dependent on physicochemical properties of it. Hansch model actually relates the biological activity of homologous series of compounds, and this method includes hydrophobic, electronic, steric factors for prediction of the drug receptor interactions. The advantages of a Hansch analysis: it is fast and easy. The predictions are very easy. It takes into account different descriptors. The disadvantages: larger number of compounds are required for Hansch analysis, and all the descriptors should be available for the substituents. Next is Free-Wilson analysis or Free-Wilson approach. It is also called additive model or de novo model or structure activity relationship model, in which the particular substituent in a specific position is assumed to make an additive and constant contribution to the biological activity of a molecule in a set of a series of chemically related molecules. So every substitution, when it is added, what happens to the biological activity that he has predicted? This approach is called Free-Wilson approach. They will study without the substituent, they will study with the substituent. Assumptions of Free-Wilson approach: it is applicable to congeneric series having common skeleton prepared by different substitutions at the same distinct positions to the parent skeleton. Advantages: it is very simpler, faster and cheaper method where no substituent constants are required. Disadvantages are the limitations. A prediction of activity increments outside the substituents cannot be extrapolated. It has less, even though it is correct, it is too simple and offers less utility to the medicinal chemists. What about a mixed approach, that is Hansch analysis and Free-Wilson analysis? So Hansch and Free-Wilson, both the equations are mixed, and this approach is called a mixed approach. It was developed to find the possible interactions between the Free-Wilson parameters and physicochemical parameters of the substituents, because Free-Wilson does not take into account the physicochemical parameters. So it is a mixed approach which is applicable for QSAR studies. What is Topless Scheme in QSAR? It's a flow diagram guided tree model which determines which analog has to be synthesized next. So there are two Topless schemes, one for aromatic and other for aliphatic substituents. Next is Craig plot. It's a plot of pi along x-axis and sigma factor along y-axis, which is useful. That's a 4-quadrant plot. Which substitution contributes to which segment? When you add this group, what will happen to the biological activity? Next is 3D QSAR. The 3D QSAR relates the biological activity of small molecules with their properties calculated in the 3D space. The 3D structures are generated with the conformational information optimized for the geometry, and the lowest energy conformation of the molecule is taken into account. The 3D approaches are classification based on intermolecular modeling, classification based on alignment criteria, and classification based on chemometric techniques. There are many techniques in this: COMFA, COMSIA, COMPASS, GERM, Combine, AFMOC and CORIA. All these models have connectivity with the alignment, connectivity with the chemometric techniques. So statistical approaches in 3D QSAR. There are 3 statistical approaches. One is a linear regression analysis. It includes simple linear regression, multiple linear regression, stepwise linear regression. Multivariate data analysis includes principal component analysis, partial least square, principal component regression, genetic function approximation, genetic partial least square. Pattern recognition includes cluster analysis, artificial neural networks, and K nearest neighbor. The assumptions of 3D QSAR approaches. There is an underlying relationship between the molecular structure and its biological activity. Receptor binding is proportional to the biological activity. The descriptors of a molecule represents its molecular structure. The observable biological effect is produced by the model ligand itself and not by the metabolite, because here the metabolites are not taken into account. The lowest energy conformation of the ligand is its bioactive conformation. For all the modeled ligands, the active site of the protein is same. So these are assumptions. It may change your whatever the QSAR approaches. If the reality conditions are different, it may not apply. How 3D approaches are validated? And they are validated by these methods. Coefficient of correlation, R2 value should be greater than 0.6. Cross validation, Q2 value should be greater than 0.5. Predictive correlation coefficient, R2 pred should be greater than 0.6. Fisher statistic parameter, overall significance should be better than 95%. The softwares used in 3D QSAR are Schrodinger, Auto QSAR, field-based QSR, Biopsy, Build QSAR, COMFA, Open 3D QSAR, and QSARINS. It's a very important question in COMFA. COMFA is a comparative molecular field analysis, which is very widely used in 3D QSAR. It was developed by Kramer. The methodology followed by COMFA are ligand selection. The set of ligands has to be selected. The receptor has to be taken into account. The ligand has to be prepared. Bioactive conformations of each molecule has to be prepared. Then they should be aligned. All the molecules should be aligned. Then field calculation. They will calculate the field around all these molecules. Then a model is generated. Usually they go for multiple linear regression or partial least square, and that displays the results in a 3D space. So it will be like this. All the molecules are put in a grid space and they are superimposed, and they study the contribution of each substitution. So this approach is COMFA approach. Next is the limitations of COMFA. Too many adjustable parameters. For example, overall orientation, lattice placement are not taken into account. Uncertainty in selection of compounds and variables. Fragmented contour maps. They are applicable to, suppose if the hydrophobicity is not quantified, it may not be applicable to the in vitro data. So next is COMSIA. It is a comparative molecular similarity index analysis. It was developed to overcome the limitations of COMFA. In COMSIA, the steric, electrostatic, hydrophobic, and hydrogen bonding properties of a molecule are taken into account. It provides a grid lattice and it takes into account hydrophilicity and hydrophobicity. Steric, electrostatic, and hydrophobic features are highlighted in the maps, where the ligands that have favorable and unfavorable regions are highlighted. What is molecular shape analysis in QSAR? It is a ligand-based 3D QSAR which merges conformational analysis with the Hansch approach. What is germ, combine, comma, AFMOC, chorea, SOMFA, and fluff ball in QSAR? Germ is genetically evolved receptor model. Combine is comparative binding energy analysis. Comma is comparative molecular movement analysis. COMFA is comparative molecular field analysis. AFMOC, it is adaptation fields for molecular comparison, also called as COMFA. Chorea is comparative residue interaction analysis. They may ask to expand this, which will be useful for you. SOMFA is self-organizing molecular field analysis. Fluff ball, flexible ligand unified force field, boundless adaptive localized ligand. What is regression analysis in QSAR? It correlates independent variables such as X, physicochemical parameters, with dependent Y variables, that is the biological data. Simple linear regression, it's an independent variable is correlated with a dependent variable which produces a linear equation. It is just a R square which you can derive from Excel sheet itself. Multiple linear regression, it is an extension of simple linear regression to take into account more than one independent variable. It is an investigation of the effect of several variables on the effect of Y. In a multiple linear regression analysis, a ratio of 5:1 is considered as absolute minimum. What is principal component analysis? It is the data reduction method using mathematical technique to identify the patterns in a data matrix. Partial least square in QSAR, it's a statistical technique in QSAR approach, where it produces solutions based on linear transformation of a large number of original descriptors to small number of latent variables. Partial least square is a standard 3D QSAR model used when independent variables are highly interrelated among themselves or when the independent variables exceed the number of observations. So it's a very short information of the QSAR and its concepts behind it. I hope it will be useful for your exam. Thank you for listening. Happy learning. Kindly share this to more of your friends. Kindly subscribe to our Pharmatopics channel. All the notes are available in Kindle Amazon also. I will provide that in the description box also. You go through all the series of videos to excel in your computer aided drug design exam of the B.Pharm 8th semester. Thank you.